Hi everyone. So for this video we're given a sign chart essentially, and what we're doing is we're going to try and see if we can understand what's happening with this function given this sign chart. Alright, so for the first thing is we're looking for intervals where f of x is increasing. So remember, that means that we're looking in the chart for where the derivative, so f prime of x, ooh, that does not look like f prime of x is greater than 0. So if I'm looking at f prime of, I'm looking at this row here. So where do I see in that row where f prime of x is bigger than 0? So I see it here, and that's it. So it looks like it's only increasing in the interval from negative infinity to negative 2. Alright, it says intervals where f of x is decreasing, so we're looking in the same row, but now we're looking for where these values are going to be less than 0. So let's see, I see it here, and I see it here, right? But it hasn't changed sign, so it's been decreasing from negative 2 to infinity. So that is going to be my interval of decrease. Alright, so extrema. So there's a couple different ways of things that you can look at this. You could look at the derivative, so f of x, and see if the sign has changed. So if it's gone from positive to negative or from negative to positive. So since we're looking at the first derivative here anyway, let's take a look at what's happening. So let's see. We've got 2 points to consider here. So let me erase some of this. So we're looking at this row, and we want to see if there's any sign changes. So it looks like there is a sign change from, so before negative 2 it was positive, and after negative 2 it's negative, right? So it goes from positive to negative. So that means the slopes of the tangent lines of the original function is positive. So it's increasing and then it's decreasing. So to me that indicates that there is a max, a relative max of some kind. And so where is that relative max? It's going to be at x equals negative 2. Okay, so if you notice here it's a positive and it goes to negative, and here it's 0, so that's telling you that that's a max or a min. So what's happening is that because it's going positive to negative, it's a max. Alright, let's take a look at the next part here. It says intervals where f of x is concave up. So if we're looking at concavity or concavity, however you want to say it, we're looking at the second derivative. So we're looking for where f double prime of x is greater than 0. So if we want concave up, we want to know where it's greater than 0. So we're looking at this second row here. Or not second row, but the last row here. And let's look at these values. So let's see, where is it positive? Well, I only see it's positive here. Right here it's 0, but we want something greater than 0. So where is it concave up? It's concave up from 3 to infinity. And then we're looking for intervals where it's concave down. So that is where the second derivative is less than 0. So let's see. Less than 0, I see it all here. Okay, and so what is it saying? It starts at negative infinity and goes until 3. So is concave down from negative infinity until 3. Alright, and the last part here, points of inflection. So remember, you're looking for two things. You're looking for where the second derivative is 0. Okay, but you're also looking for where there's a change in sign. So if it's positive, negative, negative to positive. So let's take a look at this second derivative row here. And I'm going to look at where it's 0. So there's there's only one place here where it's 0. Okay, and what I want to know is, do we see a sign change happening at all? And we do. We see that it goes from negative to positive. So now we know that that is a point of inflection, and where is it? It's at x equals 3.